Let's imagine you're an insurance company and you sell life and automobile insurance. You have a customer, Ted. He insures his family minivan with your company, and today he calls into your office to ask about life insurance. Routed to the life insurance group, he is peppered with questions we already know because the life insurance system is not the same as the auto insurance system, and in the end, Ted hangs up the call out of frustration and the sale is lost. So why did this happen? In many organizations, accessing data is difficult. Crucial enterprise data is locked in dozens or hundreds of silos, controlled by different teams, and stuck in systems that aren't able to serve new workloads and access patterns. These data silos are a huge blocker for innovation, causing businesses to miss out on opportunities and ultimately improve their customer experience. What's a better user experience? Ted calls into our organization, and the life insurance rep sees that he's already an auto customer, saving time and closing the sale by focusing on the needs of Ted and not bombarding him with demographic questions we already know. How can we solve this scenario using technology? The answer is creating an operational data layer, or ODL. An ODL can offer a best of both worlds approach, providing the benefits of modernization without the risk of a full rip and replace. In this architecture, legacy systems are left intact, so existing applications can continue to work as usual without interruption. New or improved data consumers access data, taking advantage of data originating from these legacy systems, as well as those in modern databases like MongoDB. Confluent and MongoDB are great complementary technologies within the ODL solution. With Apache Kafka, you can ingest very high data throughput from heterogeneous data producers, transform these data, and sync the data into MongoDB to take advantage of the flexibility of the document model. MongoDB is much more than a database. In fact, MongoDB Atlas is a cloud-hosted MongoDB service available on all three cloud providers and provides many out-of-the-box services like MongoDB Charts, which enables you to create powerful visualizations in minutes through a simple point-and-click web UI. MongoDB Full-Text Search leverages the Lucene search engine, making it quick and easy to search and parse text within your documents. Have a mobile application? Realm is a complete mobile database that runs on iOS and Android and can bidirectionally sync data with your MongoDB Atlas cluster without writing tons of synchronization code. Whether you're building a single-view application, offloading data from a mainframe, or performing deep analytics on heterogeneous data, there is no doubt you will save massive amounts of developer time using MongoDB Atlas in your operational data layer. Today, we will put some high-level pieces in place for you to experience how an ODL layer with Confluent and MongoDB might look. For the demo, we will take financial data from multiple tables within MySQL, stream it through Kafka into a single topic via a KSQL query, and sync the data into MongoDB Atlas. From there, we will explore two of the capabilities of Atlas, namely MongoDB Charts and MongoDB Online Archive. You can try this out yourself or follow along by downloading the GitHub repository. Once downloaded, one simple Docker Compose Up command, and within a few minutes you'll have an environment set up that includes MySQL and Apache Kafka. For more details on setting up this demo, please see the GitHub repository README file. And if you don't already have a MongoDB Atlas cluster available, you can spin one up on your own for free at mongodb.com/atlas. Let's jump into the demo. We already spun up the Docker containers and preloaded the MySQL tables using the create SQL script found in the GitHub repository. Let's take a look at the sample data. In MySQL, we have 4 tables that support this financial services application. We'd like to take these data and insert them into a Kafka topic. We do this by way of the Kafka Connect service and the Debezium MySQL connector. The Kafka Connect service is part of the Kafka ecosystem, and its job is to broker the connections between Kafka and heterogeneous data sources supporting both source and sync capabilities, meaning data coming into and out of Kafka topics. Let's configure the Debezium MySQL connector so we can stream in MySQL data into Kafka. We will define this using the Kafka REST API as follows. Now that our connector is configured, the raw data from MySQL tables will be sourced into the Kafka topic. From there, we will use KSQLDB to transform data within Kafka topics into the required structure for MongoDB. To help visualize this process, we use the Confluent Control Center. The Confluent Control Center is a web-based graphical user interface that is part of the Confluent Platform. It offers the simplest way to manage and monitor Kafka as it scales across the enterprise. Let's take a look at our MySQL connector configuration in the Control Center and check the status. You can see our MySQL connector shows up here and is configured properly and running. KSQLDB is part of the Confluent Platform, and it helps build applications that respond immediately to events by creating continually running queries, or streams. In our scenario, we want to take the data in the Kafka topics that originated from MySQL and transform it into a single JSON document structure that can easily be written into MongoDB. Let's use Control Center to define and execute this KSQL script. I'm going to break up my create stream script into two executions due to a current limitation in the Control Center UI that doesn't allow me to execute lengthy scripts. The end result will be the same. Our script created a number of streams and joined them into a single stream, transforming the data into the format we need. To best visualize the stream processing, let's use the Control Center. I'm going to click the Flow tab, and you'll notice I have my streams that were created for each table in MySQL. If I click Create Stream, I'll see the stream query itself. And if I click on the output here, I can actually see a sample data within the topic. Now that our data is in Kafka, we can configure the MongoDB connector either directly through the Control Center or through the REST API as we did with MySQL. Let's configure it with the REST API. Now for clarity, I created an environment variable called Atlas Connection that holds the connection string to my MongoDB Atlas cluster. Now that the connector is configured, let's verify it in the control panel. So go back to Connect, hit Connect Default, and we can see that my MongoDB connector is running. Now let's take a look at the data in Atlas and explore some of the capabilities within the Atlas platform. This is the Atlas UI showing a cluster I have already created to support this demo. To create a new cluster, simply select the Create a New Cluster button. As you can see, you can select any of the three cloud providers and choose a data center throughout the world. If we scroll down, we have a number of other options as far as a cluster size, different RAM and CPU configurations and storage configurations. We also have the ability to automatically back up our database and provide some additional settings such as the number of shards, etc. To connect to our cluster, there is a Connect button. If we select that, you'll notice that the Atlas UI gives us some options, such as if we're trying to connect from the shell or from an application. It will suggest connection strings for particular languages like Java and Python. Since I'm connecting through a Kafka Connect, it's most similar to MongoDB Compass as far as the connection string format goes. So I'll click that, and you'll notice that it's provided here for me with the password obfuscated. So I'll have to change that to the appropriate password I had created before. As you would expect with a production-ready database platform, we can drill into certain metrics of the database. So if I click on metrics, here it gives me the op counters, networking, database storage metrics across my 3-node replica set. I can also click on real time, and what this is going to do is show me the current hottest collections and slowest operations that are going on. Since I'm just using this as a demo cluster, I don't have a lot of action going on here, but you can see different kinds of things that you can uncover, such as the number of reads and writes, the number of queries that were executed, and so forth. There's also a performance advisor, which will actually go through and look at the queries you're executing and make index suggestions, as well as a profiler, which essentially you can set up to determine slow operations and determine the queries associated with them. So if I click on collections, this will give me the top results of the particular collection. In this case, this data, the financial data that we got from Kafka, is shown here. I can also create indexes, and I can actually build out aggregation pipelines from the UI as well. But let's face it, some of our data ages and is no longer accessed very often. Since database storage requires fast IOPS, it is not the least expensive option out there. For this reason, we developed Atlas Online Archive, which allows you to offload your warm data into Atlas into an S3 storage bucket. Once there, you can, from a single connection, seamlessly query both your warm data in Atlas and your cold data in S3. Let's see how this is configured in the UI. So I'm going to click on the Online Archive button. And the first thing it will ask me for is a namespace. So here, I'm going to specify financial data.transactions. That is the collection that I would like to use, and it's asking for a date field. So this aging is going to be based on a date field, so trans.ts, that's my date field, and I'll specify a year. So what this is going to say is that data that's older than a year will be auto-archived. The next thing it's going to ask me for is commonly queried fields, and so this helps the backend partition the archive data. So if you had a particular field that was queried frequently and so forth, you can do that here, and it will optimize the back end. If I click next, it's going to provide you a sample query. So if I take this and execute this query, it's going to show me the documents that will be moved over to the S3 bucket. The next thing it's going to do is provide an index to use to optimize this as well. So as soon as I click begin archiving, this will set up in the back end. One thing to note is I do have another connect button here. If I click on this connect button, there's another option saying connect to cluster and online archive. And as I was mentioning previously, from a single connection, so if I took a MongoDB client and I pass this connection string in there, I can issue a read-only query, and that data will span both the Atlas warm data and the cold data, which is stored in the S3 storage. So you can see this is very powerful in the sense that now I'm able to access this data, keep this data within the database, and it's much less expensive this way than keeping it in the fast IOPS. Another service that comes part of Atlas is Atlas Charts. With Charts, we can build real-time charts natively with MongoDB. Charts understands unstructured data and can easily handle arrays, subdocuments, and the flexible document schema that makes MongoDB so powerful. So let's create a quick chart off of a larger data set of fictitious stock data I had created previously. So I'm going to click Add Dashboard here. And I'm going to click Add Chart. And you'll notice I have a variety of chart types to use. So I'm going to create a line chart. I'm going to select a data source. I'm going to select my stock data. And since this data is pretty large, I'm going to enable sample mode. So it's going to take just a sample of the amount of data that's there. I'm going to create a continuous line. On my x-axis, I would like time. And on my y-axis, I would like price. And I would like the company symbol name to be the series for this chart. And I can provide a nice title here. This is my stock price chart here. And you can see with just a couple clicks of a button, I now have created this chart. And not only can I just create this chart, I can actually share this chart and embed it in web pages, either from an authenticated standpoint or an unauthenticated standpoint. So if I had a public website, but I wanted to sort of keep surfacing or refreshing this data, I can do that as well. Today, we have scratched the surface, showing you just the few capabilities of Atlas that will enable you to quickly implement your operational data layer architecture.